start with the contents, what I'll be talking about. So I'll be talking about the project that we implemented. So the talk is called Moving Towards Predictive Maintenance. So it's partly introducing streaming, and kind of word moving means that we are not fully there yet. So streaming has some complications, and when you build a system from scratch, that's one. When you are working with systems that are there for many years and trying to convert them to streaming, that's not as simple. So I'll talk about the initial idea for the project, system architecture, transformations, data ETL, what data we are collecting, how we are analyzing, and what are the results from analysis, what can we see, some insights, algorithm development, and then results of the project, some challenges and future development steps. So the initial idea for the project, so as you know, that maybe not all know, that is the telco company that provides internet services to our clients, and the idea for this project was to improve experience for our customers using data at our hand, and hopefully solve issues before clients get affected, and or offer some upgrade for the device if it's causing a problem. We are talking here about the endpoints that customers have at their homes, or update the plan. Maybe somebody is trying to use too much data and needs more speed than their current plan offers. So we also wanted to see historical data from endpoints and collect how much data is consumed by each customer, or at least in the areas, as we store also the addresses for installation. So the system architecture, if we are looking at the source system that we have some endpoints. Those are the routers, or endpoints as we call them. So that are given to our customers when they purchase our service. They're given the box that they put at home, or the technician installs it, and they have internet, Wi-Fi, and everybody is happy. So there's also a unified management platform that is kind of managing all endpoints. All endpoints are connected to it, and they send some data updates, and also that the management platform can send some commands. Our help desk can connect through that system to customers' endpoint. If they have a problem, they call in. It can be done remotely, so we can get the most fresh data from it and see what's actually happening there, and maybe sending some commands for reset that could clear some cache some data, and hopefully improve the situation without sending a technician to somebody's home, or without replacing the device. So the way, yeah, I actually did not tell about myself. I'm a data engineer, so I'm involved in all the projects that are that involve data, and I joined that 2 years ago, when that data lake was already more than an idea. It was already first platform was installed, and it was Hortonworks data platform and data flow installed on-premise as a pilot version to evaluate it, and we used this project. This was one of the first ones that to evaluate and see how this would be working. So that didn't really work out well because this working with this platform was a very steep learning curve. Lots of things were not configured correctly, so they didn't really work as planned. So second platform that we were evaluating was Azure. That was a question before the previous session, and we used for this project Event Hub to get data from that unified management platform and Databricks and obviously Spark to work with data to analyze it. So that was we got a quite good progress there. Another one was Cloudera. Those were kind of three big contestants for big data at the moment. At the moment, Azure did not have their big data storage, object storage, blob storage, something like that. I don't really remember how it was called. It was just announced. And Cloudera, we looked at the platform. It was very similar components to Horton with some differences, but by the time when we decided on the platform, we went with Hortonworks that at that time started merging with Cloudera, and now they look like this. So just because it was open source and that's kind of good because it's always developed all the components, and but also some limitations were that we were unable to start everything perfectly on our own. So we just took this for the reason of support, and now after a year and a half of working together with Cloudera, this is we have lots of projects that are already in production involving streaming. So if we go back to our project where we working with endpoints, so we still have endpoints and UMP platform, but now we have data lake. And the first thing that I also already mentioned on our project idea was to store historical data, because unified management platform was only storing one set of data for each endpoint, and when update is sent, it's just overwritten. So we didn't see a historical situation. When somebody calls in, we can only see what's there on the device. We don't know what's preceded the problem. So the data lake also gave us possibility to store this, and as we have over 200,000 devices, we didn't have sufficient system that would store this amount of data and work with that. Now we have even bigger systems in data lake, so it's a very good system, as I can see. So the structure system architecture looks like this. The endpoints send data to management platform, then it passes on to data lake. We have Apache NiFi as the entry point, and we do some basic transformations there. I also, before this presentation, I realized that maybe not everybody knows what those are, so I got on Wikipedia and got also the descriptions from there. So NiFi is the project designed to automate the flow of data between software systems, and basically it's a Swiss Army knife that kind of connects different systems. It has lots of connection points and can pass data to all the different systems and software systems. Yeah, then what we do, we receive data from UMP, and NiFi does some basic transformations and connects multiple requests, as UMP has as API. It doesn't really send us information, it sends us ID of the endpoint that just sent an update. So we are requesting then with several API calls all the data that we need. Then it's combined and placed on HDFS, Hadoop file system, then taken by Spark, that is run as services, constantly checking if new files are appearing, and transforms them, puts them into Hive. Here, at this stage, it could be improved if NiFi, for example, wrote to Kafka, or UMP could send all data to Kafka, and then Spark would take it directly. Unfortunately, in our cluster, it's not possible. Having Cloudera's support is, on one side, is a great thing, because we have lots of experience and support when we need it, but also the upgrade to newer version happens only when Cloudera decides that they can release it. So full streaming is available in Spark 2.4. We have Spark 2.3, and the Spark 2 Hive. That's the main thing. Was but still, we can run Spark application as a service on Yarn that constantly running and checking. So it's kind of micro batch, but that's what streaming is. So kind of close enough. So then we have algorithm that's developed by another team, the team of our data science, that collects the data and then produces the list of endpoints that probably have a fault in them. We send it back to UMP, and UMP initiates the resets. And that was the first project that we implemented. So we are actually looking at the data of endpoints, seeing how they are performing. We kind of detect problems, we analyze them, and then as data comes in, we are checking endpoints on those kind of parameters or attributes. If they have signs of a problem, then we send a reset to an endpoint, as this is the quickest and easiest way to solve most of the problems that our clients have when they're calling us about Wi-Fi issues. So the next slide is basically what I just told in that picture, but with words, and I don't see much point to repeat that. It's just if you're looking through that presentation again sometime. So now, what parameters we are collecting? We collect endpoints uptime. So if we can compare it to a previous uptime and see if it was actually stopped. That beside all the different log records that some routers can have, that they actually were switched off, that there was power loss. It's just depending on what device can send, because we have lots of different types, and over time, obviously, the endpoints have improved and they send more and more data. Old ones, not as much. So we also see a host list, so we can see how many devices were connected to that endpoint. So that's your PC, your mobile phone, tablets, smart devices like Hoover and so on. So we can see how many simultaneously, and also for the period of time, maybe there was just lots of people either visiting, or if it's a router in a cafe, and host lists, when it gets full, it also affects some endpoints. We see if SSID, that's your Wi-Fi name, and also there comes password if it was changed, because when you do a reset, we are not, at the moment, we are not able to recover that newly set ID, and for those routers, we are not performing resets yet, but that's in progress, and UMP can is configured now so the work is there to solve this issue. So then signal strength, again, this is only in that point of time when endpoint sends us data, but when if somebody is complaining about bad connection, that could be positioning in the house. Either endpoint should be moved somewhere, or maybe I can see that some it's better to move to a different room. Probably, like we can make some assumptions on that. Then device temperature, CPU minimal usage, CPU and memory. Again, it depends on the type of the device, what they are sending, and then not only the number of devices connected, but also MAC addresses. And from this, we could also see when we started, we only had some things that we could think of what we can solve with this data. Now, when we saw historically and we got the data that we could analyze, we saw that another use cases, kind of bonus use cases that we got from here that we could solve is to see how many clients are actually using Wi-Fi that's built in endpoints, because some are using their own devices that are connected afterwards for Wi-Fi, maybe a stronger Wi-Fi transmitter. Then we could identify connected devices. So we, in the hosts, we see MAC addresses. So from that, we could get some information online about manufacturers, about types of devices, if it's a phone or if it's a tablet. This is used mostly for checking what kind of device this is in terms of type and Wi-Fi version, because some old devices can just work badly with new endpoints, and there could be nothing wrong with the line, but the customer device that they're using is just not performing against the new environment. So then also one cool one that didn't actually work out yet, but the possibility is still there. When we got this data and security, our security department found out that we actually have it. They asked, they gave us MAC addresses of some lost and stolen PCs that were stolen from our colleagues to check if it appeared in our network at some of the endpoints after the loss or after the time it was stolen. Unfortunately, they were not, but if the next one comes, we can still check against this data, and this is something that can be done. Then for algorithm development, here we have some learnings. I will not tell about the algorithm itself. All I can say is XGBoost. It's not a secret. If you need more information on that, we can arrange. This may be at another talk, or maybe you can contact our team. It's just I'm not very familiar with that part of the project. But what learnings we got from that is that first we need to collect the data, and to train this the model, you need to have some sufficient data, and need to try to explain business why it takes so long. Then clean, normalize, repeat. There's lots of work in actually getting sensible data that can be used for the model. Then we also consult lots of matter experts, like technicians and business people, to create correct labels. For example, some at the bottom there is says that calls to help desk. If somebody calls help desk about Wi-Fi issue, this is like 100% hit for the for our algorithm. So if somebody called, okay, they have a problem, but it's too late. So things like that have to be kind of excluded. Then constantly improving algorithm using new data sources, and also using results of this algorithm not just for this project, but also for churn. So this is to identify what customers are probably unhappy with the service and could leave. So that's also some other actions can be done to kind of keep them, to offer something so they would stay. So this is, yeah, this has a duplicate for some reason. All right, so then when the system identifies from that constantly incoming data that there is some problem, algorithm creates the list of devices that should be reset. This list is sent back to UMP, and then UMP initiates resets. And this is another point in this flow where this is not exactly streaming, and for a good reason. These resets are performed at night because this is the time when customers are the least affected. We could identify potential problem right away as the data comes in, but we are not able to act on it straight away. And we only do 3,000 resets at a time for now, just to make sure that we are not causing problems. If there's some fault, that we are not causing problems to too many people. So this is from 200,000. This is quite a small percent. But if it's done every night, then we can go through all of the devices quite quickly in a week. Probably all of the faulty ones are reset. So then call center is also informed when this automatic reset happens, because there's also another issue. If password is changed but Wi-Fi name is kept the same, we have a problem. So then reset has also wiped the password back to factory settings. So that's just something to consider. And the results are quite good now, and we always trying to improve calls to the help desk decreased 3 times. So 3 times less calls from customers regarding the Wi-Fi issues, and 25% of clients do not perform manual restarts after that. So we are, as I was saying, the model is trained on the data when somebody was resetting. So it was either customers themselves or after they called help desk and they reset and they solved the problem. So this also we can see from data that comes afterwards that those manual resets are decreasing, so people don't have issues anymore that they have to solve themselves pressing the button. So, and also we are looking at the endpoints that are appearing on the list again, and for them we are now at the next stage of the project when we are looking at the line parameters. So if reset didn't solve the issue, then maybe it's the infrastructure that's before the endpoint that is affected, and we are looking to add at the moment, these line parameters are reviewed manually by technicians. Now, then from that, we'll be adding more parameters, more labels with this data to the algorithm, so it could check not just the endpoint, but also infrastructure that's outside the customer's house. So the challenges that we have for this kind of project is we have wide variety of endpoint vendors and models. So some really old ones don't send data at all. Some send partial data, and obviously the newer ones send everything we need and can use. Then obviously then data sets are different, and we have to address that in the ETL process. Then training can be done only on those customers that actually perform resets. So it's either by help desk or manual to solve some issue. If somebody has a bad Wi-Fi at home and does not do a reset, we cannot really tell if this, we cannot really use that customer for training. Then, as I said, resets can only be done at night, and with 2 endpoints that have default configuration, so nothing gets lost. And the limitation of the systems. So some systems are by design batch, and if we are using some additional data sources that cannot give us data as a stream or cannot reply to constant querying, this obviously is a problem. Now we have API calls. It would be much easier if we had data pushed to Kafka. XML is not the worst format to work with, but still could be better. And yeah, as I said already, batch systems that are already in place. It's not easy to replace them straight away, but that's something where the world moves to. So hopefully in some time will be better. So future development is to obviously improve the model, use more parameters like upload and download speed compared with line, what line has to offer. So if line can provide gigabit, then and the endpoint is not managing, then this also is an indicator, excluding people who reset routers every day, like when they just leave the house and they kill the power and then come back and then turn it on. There's a high percentage of those as well in our network, which was a surprise to me, but that's how it is. Then add some historical host lists so we can see how it's changing over time to the model line parameters. Then another thing was not just doing resets, but also cleaning the host lists. And this, from the technical team, we got an insight that this also helps. So with this, we can do also for those who don't have a stock configuration. So if you change something, password or Wi-Fi name, this can be done still to help the situation without involvement of a customer. Or we could offer an upsell for those who have maybe a bigger house or some configuration of an apartment that does not allow Wi-Fi to be received in all rooms equally, Wi-Fi extenders, something like that. But that's just ideas. So that's pretty much it. That's the project that we have now in production, and we are constantly improving. We do kind of is streaming, but not as ideal as we would want, but still moving towards it. So thank you very much, and welcome your questions.
Sorry, wasn't here.
All right.
I'm back. So we have questions. First two. So Andre is bombing his questions. So be careful. First one, I'm just publishing, and then.
Sure.
It's supposed to be that you can see them.
Yes, probably.
So first one was, do clients know about statistics you gather? And did they give a permission to gather such info?
Absolutely. The first thing that we do when we start a project, it's check with GDPR, and this data is collected to improve the service. There is no information about the client that we are not allowed to collect, and this is the first. And secondly, for those who don't give permission to analyze their data, data doesn't get analyzed at all. So in all our flows, we have first step is data anonymization for those who don't give a permission. So even if you give a permission later to analyze your data to improve the service, we will not see the data that was received before that day. And as the data comes in, if permission is not there, it gets anonymized. So yes, the answer is yes. Clients do get asked. This is to improve the service, and only data that is used to improve the service is gathered. So there is, well, actually, there's not much from the endpoints that you can get. CPU usage and number of devices that are connected to it doesn't really tell much about the client, but if there is more interest in that, I can forward this to somebody who can tell more about this, but that's definitely first step in every project that gets checked.
Okay, let's go further. Why do you use Hive? Everything could be implemented in Spark.
We are storing information. Hive is not storing. Hive is a database. Well, it's a kind of database. It's it gives SQL-like interface to query data stored in various databases and file systems that integrate with Hadoop. Again, thank you, Wikipedia. If we were just gathering some information and trying to do windowing or just process and see the results, that's one, but we do collect information over periods of time. Like if we see that if we want to check how many devices were connected to the endpoint historically, how it changed and what led to a problem, we need to store information for a week, month, possibly. CPU performance. Yeah, maybe if somebody has can tell me how to do that without storing, I'm happy to hear it.
Okay, let's go further. How many Hadoop data nodes you have for the job?
We have 8 worker nodes. They're quite big, but I'm not sure exactly how many are utilized for this job. How many cores and what's the memory usage for exactly that? I can check probably in Yarn, but yeah, I won't say. Sorry.
Okay. So next one, what was the issue with Azure plus Databricks?
Licensing costs and cost for the storage and compute power. Like it's at the start, it was quite promising with possibility to decide how much you need and you only pay for what you use. But as we were starting, it was really hard to predict how much resources we'll be using for what projects, and so we wouldn't be able to use that functionality of Azure when you are setting up a cluster just for that workload, and then as it finishes you remove it to save the cost, or you can expand it when you need it. You really need to know your workloads, you really need to know your processes. And when you are in the process of developing it, this wouldn't work out for us. So we decided to go for on-prem cluster. And we actually have now, one is under the license of Cloudera, another one is we have same structure but smaller resources for tests, some development for testing upgrades and different patches and so on. So yeah, we went with Hortonworks and Cloudera, and also another one is if we decide that we are self-sufficient, we can just cut the support and continue on our own. With Azure, you're paying for resources and it's always there. And also, as I was saying, we only announced the object storage then like 2 years ago. Now it's there, but at the moment it wasn't. So that's another thing that kind of now improves it. And again, you can pay for what you use and so on.
Okay, next question is, so there was a bit, I will change order. There's one which I don't know why I can't publish. Question is, how do you evaluate working with Hadoop? Isn't it too complex and isn't the learning curve very steep?
It was. There's lots of documentation and lots of examples. Problem there is there are also different versions, and not all versions work with each other. It took me a while to get used to that, and even with Cloudera's support, we are now we are constantly using their services. So in some way, it's kind of good that we didn't just pay and work on our own, but sometimes it's just too much of like if you are getting stuck at every step and you need the help of support to solve it, because you're unable to find information online yourself, it's kind of slowing the process. But at the moment we are at the stage when a new project comes to us, we know what tools we are using. We just talk about requirements, clarifying them, and get to work. So it was, but at the moment it's quite cool. And the Cloudera data platform, the new thing that they're releasing for like after the merger with Hortonworks, it seems very promising as well. So now when we know what we need and how to work with existing tools, the new ones, kind of we are very anticipating the new ones, new developments as well. So once you get into it, it's all right.
Okay, let's move forward. Okay, this we already discussed. So next one is, when model is set up and algorithm is working, what kind of task data engineer performs on a daily basis?
One is obviously new projects, they never stop. For the old or kind of existing projects that are already in production, you always monitor performance. That's mostly done automatically. We are just actually now finishing the monitoring process, because it's also implementing that takes some work and resources. tools are there, so it's all just take the cluster and implement it. But it's also when somebody comes with an idea to improve the model, that somebody from business sees that, oh, this data could also improve, can be used to identify the problems. Again, it's like another project. You establish the connection to the system that can supply that information, do the ETL, store information, using that algorithm, and constantly improving like that. But most of the time, once if the project is in production for some time and it already has sufficient data, it's just another project. And we have lots lined up, and there's no end to them. Like, there's lots of ideas from business, and that is not just telecommunications, it's also entertainment company. It's we have electricity, we have shops, we have where we sell again gadgets to customers. We have television, so getting all of that data and reacting in the right time is a lot of work. So we do have work. We don't sit and read the documentation all day, which kind of would be cool if we had that time to see what's new. But most of the time it's just trying to find tools to solve the problem that you have, and then working with that.
Okay, and it seems that last question. So if anybody still has any questions, ask them now. Ivans will answer to the last one. And I'm just reminding before you leave, please give us feedback on Ivans' talk, and if you didn't give yet, please give us also on Nicholas' talk as well. So last question to Ivans at the moment: do you have a dedicated Hadoop cluster for development / testing?
Yes, we do. As I mentioned, we have one under Cloudera support, so that's fully licensed, and there, if something happens, that we have support there. Another one has completely the same structure, but less resources on the worker nodes and test cluster. Instead of 8 worker nodes, we have, I think, 5. There we are testing some upgrades batches, and we are, if we want to, sometimes when support gives us a patch to install, we don't want to install it on production straight away. This didn't work well before, so we basically we got ourselves a test cluster, and we also started working on using it not only as test but also as development cluster, because sometimes, especially when data scientists are training their models, they can just get all the resources from Yarn, and basically production stops. So yeah, for all of those reasons, every system, every development system, every production system should have test, dev, prod. So yeah, we do. I think you're muted, Edgars.
Oh yeah, I'm muted, so that's why. Okay, thanks. So thank you for answers to all of the questions. So okay, one more question: do you have secured cluster Kerberos?
Yes, Kerberos, Ranger, Nox, everything there is, and it's causing a lot of, well, at least it caused a lot of problems. Now we're at the stage like, thankfully now we know how to manage all of that security. That it's kind of internal network, so it's already secured, but still we have lots of everything that's there. And when you have a problem with Kerberos, there's not much information online for the issues that you have. And this is one of the reasons why we have support of Cloudera. This is not simple. Yeah.
Okay, I'm just reminding again, please, people, please give us feedback. So far, we have excellent feedback for Ivans talk.
Yeah, Andre, I'm not sure who he is, but if you get in touch with me, that would be cool. We can discuss some things in detail.
So, Ivan, if anybody still wants to ask you some questions, I know a bit later, how can they contact you? Through me or how?
You can give my email. My work email is fine.
Okay, then if anybody wants to ask anything to Ivans, contact me. Simplest way is info@DevClub or in a Slack or Edgars@DevClub. And I will introduce you with Ivans. I mean, but we'll share email.
Yeah.
So
I can write an email in the chat if it's.
But in a chat, I can copy just a second as well. Here it goes. Here is Ivan's email. Yeah. Okay, thank you very much, Ivan, for your talk and for all the work to prepare it. It's very different when you have the work to do and then prepare the talk, and especially if you have some serious people at home in age of 1 year.
Yeah. So, yeah, thank you very much. That was definitely interesting. If somebody wants to get in touch and get some more information, let's send me an email. I'll try to answer, or at least we can have maybe a call.
Yeah,
it's also fine.
And please send me your slides, and we will add them also in a DevClub homepage.
Okay, will do.
Okay, then let's finish on it. Thanks everyone for watching. Thanks again, Ivans, for your work, and hopefully see you soon again.
Okay.
Okay, bye.
Bye.